Byte Pair Encoding comes to happyml. Hi, I'm Eric Herkus, and today I'm going to walk you through these new changes to the happyml framework. If you wouldn't mind, please like and subscribe. And if you have any questions, leave comments down below. Thank you. Byte pair encoding is a form of compression that has some specific uses in machine learning. I will give you a brief example of how it works just to give you a high level idea. There's some nuances beyond this, but I just want to give you like an idea of what's happening behind the scenes. In this example, we have 5 words: bar, barn, bard, bat, back. They all have the letter BA in them. And part of what byte pair encoding is going to do is go, oh, that's the most common pair, BA. So I'm going to replace it with a symbol. In this case, I use the spade in this example because it's an easily printable character that you can see. Again, there are nuances, but this just works really well for visualization. Once it's done that, it's going to look again. What's the next most common pair of bytes? Oh, guess what? It's spade and R. We can replace those with a new symbol. We'll use the heart. And we keep doing that process, and it slowly but surely compresses the string down. With machine learning, though, we do have to be aware of word boundaries and symbol boundaries because those are really important to the meaning of these tokens. So that is something that's part of the nuance. But again, you get the idea. It's a relatively simple idea. So how do we use it inside of happyml? You could use this byte pair encoding for something other than doing machine learning or with another framework or anything else. If you just wanted a way in C++ to do byte pair encoding, this is it. So the first step, and I mentioned it, for machine learning, we really do want to tokenize appropriately so that we get word boundaries in there. So included in happyml are a number of helper functions to tokenize text. I provide a more detailed example here just so you can see how it works with doing this append character to tokens. And what we're basically going to do is loop over this CSV. I downloaded this off of Kaggle. You could too, and it's free and easy to get. And this particular one is movie plots. So we join all the strings together. We then tokenize it so that all the words and symbols are split up into different tokens, and then we go ahead and train it. And then once we're done training, we save it. Easy peasy. So once you start training, you'll see output that looks something like this, unless you disable the output, which is an option. And it will begin working through doing merges. And you can see it did 1 merge, 2 merges, etc. And I cut off the output here because it's going to continue on. And there is a early stopping mechanism that looks at how well the strings are compressed in its validation set. And it automatically determines what's the training set, and it will split off a section of that for validation later. So you do have to make sure you have enough data. Otherwise, it ends up using your training set to validate, which is fine, but not as ideal as having a large data set that you can have a specific set of data just for validation. The reason you see the best compression started out at 1.42, you're thinking to yourself, shouldn't 1.0 be our starting point? Well, when we very begin this process, we had to remember those word boundaries, and it does add to the size of the original strings, but that's important to our machine learning algorithms. Don't worry, after you run this for a little bit, it's going to compress out really quickly, and we're going to get down to someplace maybe 0.75-ish or so, depending upon the corpus you use to train this. It can take a long time. That is part of this process, but getting good compression and good representations can really help your model along. Once we want to go to use it later, we've saved our model. We can load it up at any point using bpe.load, and then we can encode and decode strings. Now, I use this inside of the happyml framework for loading and saving data sets as a way of not only encrypting the data, but having it pre-prepared for doing training later. So that's something we'll talk about in a future video, but this is just an example, a very simple example of encoding and decoding. So there was only 5 simple steps. We'll just quick go over them again. We tokenize our data sets as appropriate to our use case. We instantiate an instance of the byte pair encoder model, we can train, we can save, and then we can just use it, which basically is encode and decode. The benefits of byte pair encoding are that we have smaller data sets, which means faster training and less memory usage, and it leads to improved model performance. Thank you so much for supporting happyml. Please like and subscribe. And if you have any questions and if you wouldn't mind, please leave a comment below. It really helps out. Thank you.